All right, so I've got a program here, basic Pygame stuff. I import math as well, might be useful later on. Initialize a bunch of variables, make the clock for the frames per second, make the surface that is actually going to display on the screen. And then we have a bunch of color variables because I want to color stuff later on. I got my main program loop. So while we're not done, while the game is still running, we're going to check for any inputs from the player. This will let us quit. I also just, whenever there's a Pygame key that goes down, I'm going to print the numeric value of that key because that's going to help me later determine like what number actually goes with like W, A, S, and D. So that'll be helpful. I fill up my surface. So this is basically like blacking out the background. And in fact, since I've already got the variable named black, I might as well use that name to make it a little bit easier to read. So I'm going to black out the screen. And going to update the screen. So any of our drawing will go in here. Drawing goes here. And then I'm going to shoot for 30 frames per second, just arbitrarily. Like, it's not going to be a really super fancy game. 30 frames ought to be fine. And then, I'm going to put an exit on the end just in case that helps us clean up when we're done right here. Okay, so I do want to emphasize objects. So let's start off by creating a square that we're going to draw on the screen. Now I know Pygame has a rectangle that is really handy, but I want to create my own version of that. So I start off by using the keyword class. Name of my class is traditional to capitalize, so we're going to do class square. And then every single class is going to have an init function, and that is underscore underscore init underscore underscore. Put self in there. This init belongs to me, the square. And we'll put in some arguments in a little bit, but let's first start off with a basic square. And the square is going to have its own rectangle, its own Pygame rectangle. Seems to make sense. So let's see. I think if I remember the code correctly, I need pygame.rect. And then I'm going to pass in an x, a y, a width, and a height. And I'm just going to make these arbitrary for now. I did say it was going to be a square, but just to make sure I have my width and my height correct, I'm going to make those different. Oh, and you can see in Visual Studio that I'm using, it actually is going to show me what I need. So it's got left and then top for x and y, and then width and then height. So that should work out fine. I'll leave these numbers in. We'll see what it looks like. So this will create a rectangle that belongs to any object that I create of type square. Let's give it a color. And for starters, all of our squares will be the same color. Let's make them really visible. Yellow will be very visible on a black background. That'll be good. And let's start off with this. Now, I haven't created any squares yet, right? If I run this, it's just going to be a blank screen. So I'm not even going to bother showing you that. So I not only have to create a square, but then I also have to draw it on the screen. So I know I'm going to need a draw function. So let's go ahead and put that in. Now, typically, I would want to leave a blank space between these two different methods, these two different functions. But since our class is really, really short, I'm going to just leave it all in one place. So draw. And then let's pass in the screen. Or actually, I named it surface above. So let's just keep the naming consistent. The surface that I'm going to draw on. But before that, I got to say self, because this is my draw function. If I'm a square, this is the draw function that belongs to me. Maybe later on, I want to write a circle function or a circle class, and it's going to have its own draw function. And then what I need is pygame dot draw. I'm going to have to look this up. I always have to look these up. Yeah, I just cheated and pasted it in from somewhere else. All right, so yeah, it takes the surface that you're going to draw on, the color that you're going to draw, and then the rectangle that's going to appear. Now, again, this does not create a square. This is instructions for how to create a square. If I'm actually going to build a square, I'm going to do that down here. I'll call it SQ for square. And then I just say the name of the class, capital S square. The capital is important. Since I don't have any arguments in the constructor other than self, which is not needed, you don't put anything for self. This will create me a yellow square at this location. And I should be able to draw it on the screen by going down here, right? Drawing goes here between the erasing of the screen and the updating of the screen. And I will say square.draw. All right, so this is our basic form. Let's run this, see what we get. Oh, I forgot to pass in the surface to the square that it's going to draw on. So I just got to put surface right here. That should work. Great. I have a yellow rectangle named square right there. Very misleading. Okay. And let's see what we want to do next. So first of all, I'd like my screen to actually be a bit bigger. I'm going to go 800, 600. I think that'll look a little bit, actually, let's go 850, 600. And then, so I've got my square. I want to be able to create squares of different colors. So I'm going to make an argument that is the color. So I'm going to pass in the color when I construct the square. So instead of yellow here, I'm going to say self.color equals color. And then this square, if I want it to be red, is now going to be red. So I run it, and there we go. We have a red square. Not very interesting. Let's go back to the code and do a little bit more interesting stuff. Let's just make a couple other example squares. We got square 1 and square 2 here. They're going to be different colors. But the problem is if I run this code, they're going to be stacked all right on top of each other because their x, their y, their width, and their height are all at the same location. So let's actually make those arguments. So I'm just going to add those to the constructor so that we can change them more easily. And instead of these numeric values, it's just going to be x, y, width, and height. Now that means that when we create a particular square, when we actually build one down here, we're going to need to pass in some kind of numeric values. Now, if I just paste in all those identical numeric values, it's going to be really boring. So this one's going to have a y value of 100, and this one's going to have an x value of 100, and this one's going to be a lot taller, and this one's going to be not as wide. And again, nothing's going to show up because now I need to remember to draw these. So I scroll on down, just real quick here. We're going to draw each of these. Now, probably it would be a good idea to just use a list, but I'm just demoing here. We're not going to be displaying just a bunch of rectangles on the screen. That's not what we're getting towards. So there's the shared screen right there. I got a red, a yellow, and a blue rectangle, and they all show up. I would like a rectangle that I can control before I worry about collisions and stuff like that. So I'm going to create a move function, technically a method, right? So functions that belong to classes are methods. And let's see, what should I do here? I'm trying to think about the best way to put this together. I think what I'm going to do is I'm going to add another variable called self.direction. And it's going to be north, south, east, or west. And I'm going to start with an E for east. And then in here, I'm going to say if self.direction equals E, then we're going to move east. So how are we going to move east? Well, we're going to say self.rectangle dot x equals self.rect.x plus 1. I'm going to move real slow, but that's okay. Now, I defined this variable, technically an attribute, which is just a variable that belongs to a class. I defined this variable up in the constructor. I did not define it inside of move. The way that move is able to get access to self.direction, the same way it's able to get access to self.rect, is because all of these self variables belong to this class, and they're available within any of the methods of the class. Now, bear with me while I quickly do the rest of these, right? If we're headed west, we're going to subtract 1 from the x. If we're headed north, Pygame's world is upside down. We're actually going to subtract 1 from y. If we head south, we're going to add 1 to y. And I could make these elifs. I'm just going to leave them as ifs for now. So now we have this move function. Great. Let's call it and make sure it works. And I'm just going to move one of the squares. I'm not going to worry about moving all of them. It's just a proof of concept, just to make sure it works. Now, I'm going to have trouble sharing my screen fast enough for this to not run off the screen unless I make the FPS lower. So I'm going to make it 5 frames per second. 5 was probably not necessary. You can see that the red rectangle moves quite slowly. but it is moving. So great, we've got movement of our object as well. So let's actually look at some of the keys. Let's press a key and we'll move our square in a particular direction. I actually have some of that code copied in another window, so I'm going to just borrow that code for the sake of time. Let's use the WASD code. So let's see here. This is not exactly the way we want to do it, but I'm going to modify it pretty easily. So we'll say if pressed 119, but that's not how we're actually doing it. So I don't have a pressed variable. That's just from what I copied it from. If the event.key, oops, if the event.key equals 119, that means the W key has been pressed. And I'm just going to fill in a bunch of these real quick, and then we'll fill in the code. So 119 is W, and A is 97, and S is 115. I'm checking another window. I don't have this memorized. That would be excessive, I think. All right, so we have WASD. So W is when I want to move north. I'm gonna say square. I want your direction to equal north. So this is another way to interact with your object, is you say the variable name that has your object, you say dot, and then you can access the attributes, the variables that belong to this object directly, just by name. And then you can set them equal to a different value. All right, so let's see if we can move our rectangle on the screen. 30 frames per second, I'm gonna drop it down to 20 just so it doesn't run off the screen before I can control it and show it to you. And again, I think I was a little too safe there. I can change, so something is going wrong a little bit, right? Here I'm moving to the right. I'm gonna press A, and I move to the left. That seems good, right, left. If I press down, it breaks. So up and down, W and S don't seem to be working. So let's try and debug that. W, north, S, south. All right, so is it up here? East, west, those are working. North, oh. I'm changing the X value instead of the Y value. You see that? Like I change the X value every single time rather than the Y value. Okay, that should be the fix. I think 30 frames per second is perfectly safe. So I'm gonna do 30, but let's check it anyway, just to make sure. All right, so I can control my square. It moves very slowly, even at that frames per second. Let's fix that, and then we'll talk about shooting, and then we'll talk about collisions. I think we should be able to get through all that stuff. So the first thing I want to adjust is the speed. And the best way to do this is to create a speed variable. Now, I found 1 to be quite slow. 5 is going to be 5 times faster. That might be a little bit zippy, but let's just start with it. And then instead of this +1, -1, -1, +1, I'm going to put plus speed or minus speed or plus speed. And the reason that this is a really good idea is if I don't like this number 5, or like I want to like have like upgrades for my square in my game, I only have to change the speed in one location, and it gets changed in, like it gets used as a variable, so that's changed value gets accessed every single time. I don't have to write special code. I don't have to put in a new number 4 places every time I want to change this. I only do it once, just in that location. Now I'm pretty confident that this works correctly, the speed, so I'm not going to demo that. Let's move on to like shooting out some other squares and see how that would look. We've shown building 1 square, so I don't need to demo all those other squares. I'm going to remove those guys. Oh, and the movement right here, it's actually better, just a little bit better, if it goes before any of the drawing. So we'll say the comment is like update game objects. And the reason for that is like you're always going to be 1 frame behind if you draw and then move. Whereas if you move and then draw, you're seeing exactly the state of the game as it exists right at that moment. So it's better to move first before we deal with any drawing. In fact, let's add another comment here just to stay organized. Get user input. So this whole chunk is getting user input. We're eventually going to have a little chunk right here where we move multiple game objects and update other things. And then just like all the drawing things and updating the screen goes right. In order to fire off little extra bullets, we're going to need a list. So I'll just call them bullets here. And we're going to put squares in this list. Now, we should get a key press to put squares in the list. I'm going to run it really quick and press the space bar just to see what the number is for the space bar. So you see 32 being printed out at the bottom there. So 32 is the number for our space bar. And so again, I'm going to make another if statement. And I like to just always just label these because, you know, who remembers what the number 100 is or 32 is? Like, I like to say space bar. And then what I'm going to do is I'm going to put a new bullet in my bullets list. So start with a comment, fire a bullet. I haven't put anything in the list yet. This is just like a placeholder. I need to create a square. So since we have a square class, just all my bullets are also going to be squares. So I'll call it B for bullet. It's going to be a new square here. What color should it be? Red seems good, but if red is going to be our bullet, let's make our player green. This location is probably not great. We probably want to put it at the location of the player themselves. So our player is named SQ for square. So we could say, we can't actually say sq.x. That would be nice. But we have a rectangle, so we can say sq.rect.x, excuse me. So there's the x coordinate, and then this will be the y coordinate. And then our bullets should probably be pretty small. Let's make them little 10 by 10s. Let's make them 20 by 20s. I'm not sure how good the video is going to be, so let's make them visible on screen. And then I append them to the bullet list. But this is not all. It's a very common mistake, especially when you're creating your first Pygame, to do this and be like, great, I got bullets. Let's run it, and there should be bullets on screen. It's really easy to forget to draw them. So we got to draw these things. I'm actually going to draw the bullets before I draw the player so that they appear like underneath the player and they look like they're coming out from below rather than like spawning right on top and then flying away. I'm going to use a for loop. So for B in bullets, I don't have to use a for I in range, although I could. I will probably use a for I in range later, but this is just a little bit easier to type out. So for B in bullets, B.draw, and then I pass in the surface that they will draw on. All right, this is going to mostly work. I would like you to try and guess in what way it's not going to work. If I press the space bar, I want you to have a guess as to what's going to happen. You don't have to say it out loud. So here I'm going to start pressing the space bar. So there's actually, I'd say, two things that are really maybe not ideal about this. Bullets need to move. Yeah, the other one is a little bit less of a problem. What's the other kind of weird issue? Well, I'll fix the move while you think about it. So I update the game objects right here. It doesn't really matter what order we move things in. So I'll just move the, actually, you know, just for consistency, we'll move the bullets first. It doesn't really matter too much. So instead of B.draw, we're just going to say B.move. We'll tell all the bullets to move. Oh, and the other thing that we should do is we probably, I mean, you mentioned Galaga. So let's just like call their direction north, just so they move north. I mean, we could change that very easily, right? But this is just will be their default direction right here. All right, so the bolts should move now. The other issue is that they're all going to spawn at the upper left corner of our square here. And actually, I don't like the dimensions of the square. So 100 by 200 is a bit much. Let's make 100 by 100. And let's like center it more on the screen. Let's start its XY off at 200, 200. So our bullets should move now just from these two little lines of code. And this is the beauty of classes, is that I wrote this movement function for our player, and now I just get to totally reuse it right? I wrote 2 lines of code, and our bullets should fly at this point. And let's actually verify that before I get too far ahead of myself. Yay. Okay. So the issue that I'm just going to give a little quick fix for is that they all spawn out of the upper left corner. They don't spawn out of the middle. So instead of spawning at the square.rect.x, what we're going to do is we're going to spawn at square.rect.x plus the square.rect.width divided by 2. We're just going to cut the width in half, and then that way it'll look more like they're in the center. Now, what we should really do is also take the width of the bullet and subtract that off. You know what? I'll do all this, but like I'm going to name it spawn x, because otherwise that line of code gets really gnarly to read. So spawn x is this, and I'm going to space it out just a little bit. So this will center our bullet. It'll still fire from the top of our rectangle, but at least it'll look a little bit better. So I'm going to leave that on just as it is. Oh, by the way, if you want to make your bullets move faster, probably do that. Bullet speed equals 10. Make them move twice as fast as the player. That could be nice. So little changes here makes big changes in our game because we're reusing all of this object code, all this class code right here. I feel like before we do collisions, the one other thing we need is like something to shoot at. So let's do something similar to bullets, and we'll just make some enemies like cascade down the screen. So we'll make some enemies move down the screen, and what's the best way to do this? I want to keep it simple is the only issue. So, you know, to keep it very, very simple, I'm going to import random, and we got 30 frames per second. I'm going to make it so that an enemy spawns maybe every 2 seconds. And the way I'm going to do that is I'm going to say if random.randint, and the randint is going to go from 0 to 60, right? So there's 30 frames per second. So if I pick a random number between 0 and 60, actually 1 and 60, since randint includes both ends. And then if I just say this like equals, it doesn't even matter, just some number in that range, then on average, I should spawn an enemy every 2 seconds on average. Sometimes it'll be more, sometimes it'll be less. So let's just like see how that works. Our enemy is going to be a square. Oops, excuse me, a square. And let's make the enemies yellow because that's a color we're not using right now for anything else. And their Y value is going to be easy. Actually, let's make them bigger than bullets but smaller than the player. So their width and height will be 40. Their Y value, I'm going to make -40. So they appear just off the screen, just barely off of the screen. And then the X value, let's actually just put in X and we'll get a random number for that because I want this random number to be between the edges of the screen. So between 0 and not actually the far right side of the screen, which I don't even know what it is. Okay, so this is, it's time to create variables for these so that we can reference them down below. All right, and now we're going to use the screen width to spawn our enemy. So the X value is going to be from 0, not actually to screen width, that's going to turn out bad, -40, so that no matter what, the like square is actually on the screen, right? If we set it to screen width itself, we could have the box like have like 1 pixel on the screen and like all the remaining pixels off to the right, and that's not ideal. So enemies.append E. And now, although it does require some more code, we're going to do something very, very similar to what we did with the bullets. So here we looped through the bullets and we drew them. Now we're going to loop through the enemies, and we're going to draw these. And it doesn't have to start with the same letter as your list. I just find that makes it a little bit more memorable. So here we loop through and we draw the enemies. And let's actually do the similar thing up here. Let's loop through and move all the bullets. Does anybody see something that I have left out Like before I could just like run it right now. Anybody know what I left out?
The enemies are just going to go to the right, right?
The enemies are just going to move to the right, yeah. So we should do a similar thing that we did with the bullets and change their default direction or their starting direction to south. So we spawn enemies on the top of the screen and tell them to move down. Now, I wrote a lot of code there. I probably should have done some testing, but it's kind of obnoxious to share my screen. So let's see what we got here. Oh, hey. Well, we got a chunk of them. Gonna get any more? So the randomness here makes it a little bit difficult, right? So like they sometimes like all spawn in and sometimes they don't. Like on average, this is 1 every 2 seconds, but like it's not ideal, I think. Like there's some more. Let's spawn them at least a little bit more frequently. And it shouldn't matter what number I choose to set it equal to, but I have weird paranoias that I think I should set it as something in the middle. It really shouldn't matter. All these numbers should be equally likely to be chosen. So the 15 doesn't matter. But I'm putting it there anyway. So collisions. We'd like to collide with our little enemies that we created and remove them from the screen. The way we're going to do that is we're going to create a collision function in here. Now, you'll notice that I keep moving my draw function down. That's just a matter of personal preference. I usually keep it at the bottom because it's usually like one of the least likely things to be changed, at least for me, if I'm just happy with rectangles. So I just keep it at the bottom. It's also a way that like draw like really feels to me like it belongs in a class. So like I remember, now the indentation should tell you like that this is still part of your class, but it also just like is a reminder to me that, you know, this is still part of the class above there. So collided, and we will take an other rectangle and we're going to check to see if we collided. And Pygame provides you with some really nice functionality for collisions. And again, I'm going to totally cheat and just copy it out of another window. The way you can tell if 2 rectangles collide is you can call rectangle.collideRect and pass in another rectangle. I'm going to break the comment, return true if self collided with other rect. And otherwise, return false. And all I need to do for that is just return. Well, I need to spell return correctly. I'm just going to return this function right here because that's what this function does. Now, I like putting this inside of a method because there might be other ways that we want to collide with things. It's pretty easy to tell if 2 circles collided with each other, for example. It's a little bit harder to determine if a line crossed a circle or a line crossed a rectangle or another line. But suppose we want different sorts of collision or we want to respond to collisions, it's good to have a function available, even though it's only really 1 line of code right here. So we've got our collided function. What's left to do is check for collisions. And I'm going to do that in, you know, under this updating game objects, maybe after spawn enemies, we'll just check for collisions here. So I'm going to say for B in bullets, same as I did above. And then I'm going to loop over every single one of my enemies inside this loop, right? I need to check for each bullet, did it collide with any of the enemies? So I got to loop across both of these. And then I'm going to say if b.collided with not just the enemy, because remember it takes a rectangle, but the other rect. And then I'm going to do something. And for testing, I'm going to put in a big capital testing right here. I'm going to change their color to some color we're not using, like white. All I'm going to do is change the color. So e.color equals white. And that's it. Let's see how that works. Well, something went wrong. It doesn't like for E in enemies. Oh, because I didn't write the word in. Fair enough. For E in enemies. Okay, let's try that. Let me try and shoot some of these. Oh, okay. I turned 1 white. Get him. All right. Okay, so I'm detecting the collisions, and I'm changing the color of the enemies. Probably you want to delete them off the screen. Maybe you want to delete the bullets too. I did this on purpose to show you that it's pretty much working, because there's a problem if you just try to say enemies dot remove E, and you try and say bullets dot remove B. This seems sensible. I'm just going to remove the things that collided from their lists, and then they should go away. And let's see what happens when I do this. Pew. So I need more than one on the screen at the same time, I think. Right, are you serious? This is just going to work? Okay, I'm a little confused. I thought this was going to break. I want to show you a safer way of doing this anyway. It can be dangerous to remove things from a list while you're looping over that list, but apparently this is safe with these removes. I was going to do it a much more complicated way. I'm going to show you the complicated way, but apparently this is excellent. So, hey, I learned something today. So I'm going to leave this in here. And what I'm going to change, though, is I'm going to do for I in range length of bullets. And not only that, but I'm going to reverse this. So this is the way I always used to do it. I mean, and sometimes you need to do it this way for other reasons. But I'm going to loop in reverse, and I'm going to get the index of the bullet. And I'm going to do the exact same thing for the enemy, but I'm going to use J because I need to use a different variable. I got to change it over to the enemies list. And now I'm going to say if bullets bracket I collided with enemies bracket J, and then I'm going to delete enemies bracket J. And I'm also going to delete bullets bracket I. Furthermore, I'm going to break out of this inner loop. We don't need to loop over and check to see if a dead bullet is colliding with any further enemies, right? The bullet's dead. It goes away. Now, this is the way I always used to do this. I thought you had to reverse things because it's dangerous to remove things from a list while you're looping over the list. But apparently, this is a nice, clean implementation. I mean, one of the reasons is I almost never use remove. I usually use delete. But apparently, this either way will work nicely. Now, let me make sure that my new, more complicated way is just as good as the older, simpler way. So it appears to be working here. I really should move my movement speed up. It's kind of hard to get over in time to get these things. But yeah, this also appears to be working just fine. Okay, that's 40 minutes. I'm happy to end class there, and I think even I have an idea for next time. I could show you next time how to shoot bullets in any direction. You just like mouse click and fire in any direction. And I think that'll be good to do next time. So good little review of objects, I hope. Right? We use the same exact object for every single one of our game objects, right? The player, I should probably rename this, the bullets and the enemies are all squares, different colors, different sizes, different movement. But that's all it took. And that's the real power of classes, is reusing code and making it do lots of different things for you rather than rewriting. So the total length of our game, including comments and blank spaces, is 111 or 110 lines of code here. And you see a lot of that is, removable and not needed. So that's kind of nice.